Okay, good morning, everybody. So welcome to this Friday edition of your weekly Math 174. No? Friday na, yay! Makakapagpahinga na uli tayo. Parang ang daming nangyari this past week. Though Fridays for me had been a bummer for the last few Fridays kasi meron akong klase ng 5:30 to 7. So kahit gusto ko nang mag early hibernation o gumala ngayong Friday, hindi pa pwede kasi may 5:30 to 7 class pa ako. Pero I think that would be my last 5:30 to 7 at least for now kasi may ka-team teach ako doon. But anyway, so here we are in Math 174 module number 6. We'll try to finish the remainder of this module. Mukhang maiksi na lang naman to, so that we'll have a quick laboratory exercise on Monday. So yeah, let's see. So this chapter is about developing numerical differentiation techniques. Kasi yun nga yung promise natin, ano? Yung Math 174, i-address niya yung mga basic disconnect between elementary calculus, your Math 30 series, plus real life applications. Because in real life, we don't get, or we are not as lucky as to get continuous functions or a function in general to model natural phenomenon. Data comes in discrete sets, all right? So patingi-tingi yung mga data. So ang problema, paano ka makakuha ng function that will mimic your data? Then how do you do differentiation and integration with only a limited amount of information? So nasagot din natin yung first problem in the first half of the semester when we develop interpolation techniques. How to come up with a function. In our case, we come up with a polynomial that will mimic the given data in such a nice way that the mimicking function or the mimicking polynomial, which we call an interpolating polynomial, will pass through all of the given data points. Tapos ang kagandahan nun, as any numerical analyst will do, tiningnan natin ano yung error na incurred in that approximation. Now, pumunta na tayo ngayon sa pangalawang basic chunk of the course, which is finding numerical differentiation techniques. How do we estimate the derivative even though we are only given a discrete set of points, right? So, ang ginawa natin, we have seen actually both approaches last time already. The first one is you interpolate the given data, right? So, kung binigyan ka ng n+1 points, para makakuha ka ng estimate para sa derivative at any point within the interpolatory interval, meaning the smallest abscissa and between the smallest abscissa and the largest abscissa, pwede mong gawin, meron kang n+1 points, kunin mo yung interpolating polynomial of degree at most n na daraan dun sa n+1 data points na yon. So you get a polynomial, and lucky for us, polynomials are easy to handle. They are very smooth. So ibig sabihin, nag-exist yung derivative ng polynomial at madali siyang computin, right? Even MATLAB can find the derivative of any polynomial for us. So meron kang degree n or at most degree n interpolating polynomial, then you get the derivative, you get a polynomial of degree at most n-1, and you just plug in x's from your interpolatory interval and you get estimate for any derivative or for the derivative for any x in the interpolatory interval. And that's that easy, all right? Although that process is quite expensive because you are doing a two-pronged process. Number one, you're taking the interpolating polynomial, and second, you'll differentiate. And then actually may third part pa, magpa-function evaluation ka pa. Magpa-plug in ka pa dun sa derivative. So kung hindi mo naman kailangan yung yung estimate para sa derivative at all x's within the interpolatory interval, then that process is an overkill. Kasi ang ginawa mo, gumawa ka ng formula na pang-estimate sa lahat ng derivatives within the interpolatory interval. What if all you need is an estimate for the derivative at a particular x value? All right? Na wala dun sa given, na pwedeng nandun na sa data points, all right? Which is usually the case. So, yeah, that process is quite an overkill. So, titingin pa tayo ng isang method paano makakagawa ng mas efficient na numerical differentiation formula. And by the way, that first process that we talk about sa yung paggamit ng interpolating polynomial sa pagde-differentiate ay may kaakibat na mga issues. Okay, na i-inherit niya or na-inherit niya lahat ng issues mula sa interpolation. All right? So, especially now, data comes in big volumes. So, kung marami kang data points, pag kinuha mo yung interpolating polynomial, napakalaking degree. Right? So kung napakalaki ng degree niyan, so pwede kang magkaroon ng Runge phenomenon. So the error due to the Runge phenomenon in the interpolation process will be inherited by the numerical differentiation formula that you have. So aside from the error in the differentiation, dala-dala mo pa yung issue ng Runge phenomenon. Well, of course, you can say, sir, I can combat the Runge phenomenon by using piecewise linear interpolants. Pero you need to be careful if you are using a piecewise linear interpolant because a piecewise linear interpolant is not always differentiable. Right? Kasi nakita natin, pag nag-connect the dots ka, pwede kang magka-sudden turns. So you go to cubic splines or quadratic splines, that's good. Which reminds me, pwede kayo mag-quadratic spline sa project, sa final project. So that's another idea for you. So, yon. Although that entire process, as I've mentioned earlier, is an overkill. All right. So, tumingin pa tayo ng isang method to find the numerical differentiation formula. And nakita natin ay yung paggamit ng Taylor's theorem, which is basically the Taylor series expansion. So here we're expanding f to get the value of f of x plus h, right? So ito yung nakuha nyo na from Math 38. Although it's in a more generic form because before what you're doing is an expansion of f of x, right? Using x minus a's, right? So ang ginamit nyo ay expansion ni f about the number a, right? Or if a is 0, then you have the Maclaurin series expansion. Pero we just rephrased everything, so we replace x by x plus h, and then x minus a is replaced by your x's, ano? So ito yung gagamitin natin, formula 6.6 to start with a formula. But of course, we will not stick with equation 6.6 long because this is an infinite series. So we need to truncate this to the first few number of terms so that we can use machines to do the calculations for us. So that's why we need equation 6.7, which is the truncation of the Taylor series expansion to degree n. All right. So usually, kukunin mo lang exactly yung first n plus 1 terms, right? So simula dun sa zero order term hanggang sa order n term in terms of the variable h. Tapos ang sinasabi ng equation 6.7, yung truncation error. Pag pinutol mo siya hanggang dun sa first n plus 1 terms lamang, yung error you incur is actually this guy. It's a multiple of h to the n plus 1, all right? So this is basically h to the n plus 1 times some constant. What is that constant? That is the n plus 1 derivative of f evaluated at the number c all over n plus 1 factorial, where c is a number in the neighborhood of x. Hindi siya dapat capital X. All right? And in theory, we want h to be very, very small. All right? Gusto natin maliit si h para maliit lamang yung error. Because if h is small, and then n plus 1 is a natural number, because this is the exponent to the series, to the terms in the series expansion, pag maliit si h, maliit yung h to the power n plus 1, this is just a constant, so we get roughly a very small number for the error. Okay? So yun yung idea. Gusto natin maliit si h, tapos magka-truncate tayo. Of course, theoretically, the larger the value of n that you leave in the expansion, the better, which makes sense, right? Kung si f of x plus h ay equals sa infinite series na to, then the larger number of terms that you keep, mas accurate, right? Kasi kung infinitely many terms yan, it makes sense na pag gumamit ka ng 10 ng degree 10 Taylor polynomial, mas maganda yon kesa sa degree 5 Taylor polynomial kasi mas marami kang terms na kinikip. And that intuitive notion is verified by the error term in equation 6.7. Because here we see when h is an infinitesimal number, h is a number much less than 1, then this guy will approach 0 whenever n is very, very large, right? Regardless of the value of the n plus 1 derivative at the constant number c. All right? Tapos nakita natin, I guess last time, we derived a 2-point forward formula of order n. It's a 2-point forward formula kasi gumamit tayo ng dalawang function values. Gumamit tayo ng f of x plus h at saka f of x. And then it is called forward because we are moving forward in the x-axis to find the data in our formula. All right. In this particular case, we are estimating the value of the derivative at number x. Dahil forward formula yung yung gusto nating i-derive, nag-move ako from x one step forward, nakarating ako kay x plus h. So, and then 2 points, dalawa yung ginamit kong function value, si f of x at saka si f of x plus h. Right? So that's why it is called a 2-point formula. And the order of the formula is 1 because the error term is a constant multiple of h to the power 1. So kung ano yung exponent ng h dito sa big O notation, siya yung order ng formula. Right? And this is interpreted as kapag ka mayroon kang error na big O of h, that means the error vanishes as fast as how h approaches 0. So magkasing bilis nagsi-0 yung step size h at saka si error dun sa interpolation. So ganun natin siya ini-interpret. That's why it's very important that you take note of the order of the formula. Because the higher the order of the formula, theoretically, the better the approximation becomes. Kasi yung plus big O of h to the power n, siya yung nagsasabi gaano kabilis nagsi-zero yung error. Okay? But we'll see some complications about that. Parang laging ganun naman sa Math 174, ano? Parang ang perfect na nakukuha nating formula, tapos next meeting, babasagin natin yung illusion that we have a perfect formula because we will take note of some issues, especially regarding the implementation of the theoretical method. Okay? Now, looking forward to today, what we'll do is to find a way, or I'll teach you how to find several types of formulas. All right? So, bibigay ko kung ilang points yung gagamitin, sasabihin ko yung direction of your motion, if it's forward, backward, or centered, and then sasabihin ko kung ano yung order of the approximation. All right? Now, let's see. Okay, let's jump to example 6.1 right away. Nothing beats talaga a very scalding hot cup of coffee in the morning. But anyway, example 6.1. Here we want to find a 3-point forward formula of order 2. So yun yung ating kailangan gawin dito. So here are the things that you need to look out for. Ulitin ko lang yung sinabi ko kanina. So 3-point, so kailangan ko ng tatlong function values na gagamitin para i-derive yung formula kay f prime. And then it's forward. So the understanding here, by default, ang gagawin natin, kukuha tayo ng estimate para kay f prime of x. So dahil 3-point forward formula to, gusto ko ito ay maging isang function, alright? Kailangan ko humanap ng formula. Ano dapat yung mga parameters dun sa formula? Well, we're doing a 3-point forward formula. So kailangan ko yung function value kay x. Tapos kailangan ko pa ng dalawa pang points. And then sabi ng instruction, forward formula dapat. So I need 2 steps from x. So I'll need the function value at x plus h, and then I'll need the function value at x plus 2h. Oh, by the way, this is one convention in the formulas that we will use. We will assume that there is a uniform step size, just for simplicity. All right? Though there are expansions na posibleng magkakaiba yung step sizes for, or magkakaiba yung h sa bawat step. So pwedeng ito ay f of x plus h, tapos yung susunod mo ay f of x plus another step size na yung result nito ay mas malaki rito. But anyway, You can look into it in your projects, all right? But for this module, i-assume natin na uniform yung increment between the abscissas or the x's, all right? Tapos order 2. So ibig sabihin, dapat ang formula natin ay may plus big O of h squared. And we expect that the whatever formula that we get should be better than the 2-point forward formula of order 1 that we have developed last time. Because now, if I have a formula of this form, ibig sabihin yung formula na to or etong estimate na to para kay f prime, ang error dyan ay mag-approach ng 0 kasing bilis ng pag-0 ni h squared. And whenever h is an infinitesimal number, meaning h is a small number, a number less than 1, ibig sabihin mas mabilis mag-0 yung h squared kaysa sa pag-0 ni h. That's why as much as possible, you want a formula of higher order. But of course, there's no free lunch in the world. Law of equivalent exchange nga ng Full Metal Alchemist. Kapag ka gusto mong mag-gain ng something, dapat mag-give up ka ng something of the same value. So, ibig sabihin, kung gusto mong mas accurate, meron kang isa-sacrifice, right? At ano yung obvious sacrifice natin dito sa pagkuha ng 3-point forward formula of order 2? Sige nga. Ano yung give up natin? O ano yung sacrifice na ginawa natin? Mas malaki nga yung mas mabilis nga mag-zero yung error para dito sa i-derive nating formula, pero at what cost compared to the 2-point forward formula of order 1? Yeah. Kailangan ko magtanong para makahigop ako ng kape habang mainit pa siya. Sige, anyone? Any guess? O paano na yan? Paano pag nagpa-essay na naman ako sa next problem set, Pero napansin ko yan. Sa 174 yata last, or sa 155, 2 semesters back, mahilig ako dun sa kayo yung hindi nyo sasagutan lahat sa problem set. You have the liberty to pick some of the items, Ginawa ko sa 155, parang meron akong 5 questions. Yung 4 proving, yung isa ay essay. Tapos I told my students, just choose 4 out of 5. And to my surprise, ang pinaka-konting pumili ay yung essay question. So, yeah. Kaya next problem set sa kanila, ginawa kong required yung essay question para hindi sila makatakas. Pero anyway, the idea here is we get a better formula, a formula where the error vanishes faster at the cost of using more points, right? Dun sa order 1 formula, gumamit ako ng 2 points. Pero dito, sa order 2 formula, kailangan ko ng 3 points. Actually, I guess this is the minimum number of points to get an order 2 formula, right? So yun yung magiging sacrifice natin. Gagamit tayo ng mas maraming data, and more data means more operations to be performed. But that's not a big issue, or that's not the big issue here, because you will see that basic arithmetical operation lamang naman yung gagawin natin kay f of x plus h, at saka f of x plus 2h to get an estimate for f prime. Alright? So pero kung hundreds na yan, medyo marami ng issues yung involved. Right? But essentially, let's see. This is the plan. Use f of x plus h, f of x plus 2h, and come up with a formula of order big O of h squared. And what we'll do now is to go back to Taylor's theorem, theorem 6.1. Kukunin natin yung expansion para kay f of x plus h at saka kay f of x plus 2h. Yung expansions para sa kanila ay meron ng f of x. So I don't need to worry where f of x will pop up in the formula or in the derivation. Okay? So, ayun. Kunin ko muna yung Taylor series expansion. Well, f of x plus h can easily be expanded, using, kopyahin mo lang yung nandun sa formula 6, sa theorem 6.1. Medyo magkakaroon ka ng problema sa expansion ni f of x plus 2h. But that's not a big problem because if you go back here in formula 6.7 or expansion 6.6, yung h, lahat ng instances ng h, palitan mo lang ng 2h. You will get the expansion for x plus 2h. Alright? That means dito, f of x f of x pa rin, plus h will be replaced by 2h, so you'll have 2h f prime as your second term. Here, h inside the h squared will be replaced by 2h. So instead of an h squared here, you will have a 2h quantity squared. So you will have 4h squared f double prime of x all over 2 factorial for the third term. So this guy, h cubed, will be replaced by 8h cubed, f triple prime of x all over 3 factorial. All right? So that's how you get the expansion when this h is replaced by some other value. Okay? I hope that's clear. Paulit-ulit niyo yung gagamitin. So I hope you remember that trick. Now, you can check that f of x plus 2h will get this form. And then we use the exact expansion, at least for now, because we also want to get what you call this. We want to get a good idea of how big the error is aside from the order. We want to get also an idea about the theoretical error. Okay? Now, so expand muna yan. And then, paano natin malalaman kung sino yung gagawin kong ... Alright? Sino yung hindi natin masyadong papansinin? Well, makikita nyo yan dun sa order. Order 2 yung gusto kong formula. Alright? Order 2 yung gusto nating formula. But remember, when you're taking f prime, pag tinignan nyo yung mga expansion na to, or even we focus here in this expansion, si f prime ay may coefficient na h. Alright? Or meron siyang coefficient na constant multiple ni h. H to the power 1. So essentially, if you solve for f prime here, you will have to divide by h. Right? Kasi para ma-isolate mo si f prime to one side of the equation, etong mga to, ita-transpose mo dun sa kabila, tapos to have f prime exclusively on one side of the equation, you need to divide by h. So essentially, any formula for f prime using these two expansions will require us to divide both sides of whatever equation that we'll come up with by h. Right? So, ibig sabihin, kung magdi-divide pala ako ng h in the long run, in the final steps of my solution, gusto ko yung error, yung truncation error ay na matitira ay h squared. Right? Eh yung error, di ba, ay h to the power n plus 1 all over n plus 1 factorial times f to the n plus 1 derivative ni f evaluated at c. Pero sabi natin, in the long run pala, maya-maya, magdi-divide pa ako ng h. So, dapat yung error ay magiging h to the power n lamang. So, gusto kong error ay big O of h squared. Pero remember, h squared will be derived after dividing a power of h. Kasi nga si f prime ang coefficient niya ay h. So, ibig sabihin, kailangan kong i-take into account in details hanggang dun sa h cubed term. Alright? So, kaya dito, dun sa expansion, though infinitely many terms yan, ang kailangan ko lang talagang isulat ng detalyado ay hanggang dun sa may h cubed. Right? Because again, pagka nagkaroon ako ng h cube, pag mag-isolate na ako ng f prime, i-divide ko both sides by h. So lahat yan madi-divide by h. So I will have an h cube here divided by the h later. So magkakaroon ako ng h squared. Yun yung pinaprepare ko para dun sa error. Okay? So laging ititira nyo lahat ng terms na ang degree ay less than or equal to dun sa order plus 1. Right? So, ang order ng formula na hinahanap natin ay order 2. So, ikikip ko hanggang h cube, 1 order higher. Right? Okay. So, here we have the expansions. Alam na natin kung hanggang kanino yung ating titingnan ng detalyado. The rest will be represented by the ellipses na lamang. So, et al na lamang sila dun sa ating expansion. But here, we cannot accept all of the terms here because our assumption is ang meron lang tayong access ay yung function values. So we can keep f of x plus h in our formula. We can keep f of x plus 2h in our formula. Then of course, f of x pwede yung matira dun sa ating formula, that's fine. So all of the yellow terms can stay in the formula, right? Tapos itong may f prime, magstay yan kasi kailangan natin ng f prime sa right-hand side o dun sa isang side ng equation kasi gusto natin ng f prime equals something. So we don't want f prime to be out of the picture. All right? Tapos, ang error term natin ay manggagaling dito sa mga may h cube. Right? Kasi nga, order 2 yung formula na gusto natin. Tapos mamaya sa dulo, magdi-divide ako ng h para ma-isolate si f prime. So, ibig sabihin yung error manggagaling dito. So, dito manggagaling yung factor ni h squared na magiging error natin. So, that leaves us with two unwanted terms. Ayaw nating matira dun sa formula yung may mga f double prime. And for obvious reasons, because we are assuming that we don't know anything about f prime, much more, we don't know anything about f double prime, right? So, ibig sabihin, wala tayong access sa f double prime. So, dapat yung formula nating madiderive, wag mag-involve ng f prime. Okay? So, I want these two terms to be eliminated in our formula. So, the thing here is, we need to think of what should be the multiplier to the first equation and the second equation. So what our capital A and B should be so that when I add the two equations together, dapat maka-cancel yung may f double prime na term. Okay? So pag sinimplify natin yung constant coefficients nito, para silang may h squared f double prime. So we don't need to worry about that. So ang constant ng una ay 1/2. Yung constant ng pangalawa ay 2. So gusto natin ma-cancel yung may mga f double prime. So ano dapat yung pang-multiply ko sa first equation at pang-multiply ko sa second equation para mag-cancel out yung may mga f double prime. Okay. So here I want to cancel 1/2 by 2. So ibig sabihin kailangan ko itong i-multiply ng 4. I-multiply ito ng 1 para yung coefficient na to ay 2. Coefficient na to ay 2. Tapos pipili ako sino yung lalagyan ko ng negative. So it's up to you to choose sino yung magkakaroon ng negative. But I guess in the module, I chose to attach the negative sign to 4. So when I multiply both sides of the first equation by -4, the coefficient of f double prime will be -2h squared. And then if I retain the coefficient of f double prime, so that's going to be 2h squared as well. So if I add these two guys, -2h squared f double prime plus 2h squared f double prime. So this guy will be eliminated. So that's why I will have f of x plus 2h minus 4 f of x plus h plus the results when we add the multiples of the two right-hand sides. All right? So multiply nyo lang lahat ng term dito by -4. Multiply nyo lahat ng terms dito by +1. You add them together, you're going to get this one. Okay? And again, we don't need to pay attention to all those terms beyond the cubic term in terms of h kasi mapapasama lang sila dun sa truncation error later. Right? And so we will come up with this right-hand side. So is this process clear? Okay naman? React naman kayo, guys. Thank you. Okay. Tapos, meron ka na lang ngayong isang parang polynomial in the variable h. So ngayon, i-isolate mo lang yung may f prime. Okay? So dito, ginawa ko ito. Nilipat ko dun sa left-hand side. So naging 2h f prime siya. And then everything that is originally on the left was transferred to the right-hand side. So you will come up with this here. And then as promised, the final step to get f prime will be division by a multiple of h. Nakita natin in the end, merong 2h na coefficients sa f prime. So we divide both sides by 2h. And when we do so, ito yung makukuha kong simplified form. Okay? And then again, we don't want the reason why we just canceled f double prime at tinira ko yung f triple prime kasi yung f triple prime siya yung magsaserve na truncation error. Because again, according to Taylor's theorem, this guy, okay, yung nakikita nyo dyan, pwede siyang mapalitan ng h squared over 3 f triple prime of c, where c is a number in the neighborhood of x. But essentially, the idea there is f triple prime of c is a constant number. And whenever talking about big O notations, we don't care about constant multipliers. So hopefully you have seen that in AMAT 152. If you forgot about it, download the complete vortex that I wrote for 174. Meron dun section sa big O notations. So think about it. But sa big O notation, dinadrop lang natin yung constant multiplier. So we forget about f triple prime of c all over 3. We just keep h squared. And we say that the error is of order big O in h squared, right? So that means we can use this formula to get an estimate for f prime of x. And this formula is of order big O of h squared, or it is of order 2. So that means the error vanishes as fast as how h squared approaches 0. Remember, si h siya yung step size. Magsisimula ka kay x, tapos ang susunod mong data na gagamitin ay yung function value kay x plus h, tapos ang susunod mong data na gagamitin ay function value kay x plus 2h. Now, if you make h small, the error will also become smaller, and the error becomes close to 0 as fast as how h squared will approach 0. So really, intuitively, this formula seems to be faster than the convergence of this formula, right? Kasi itong formula na to, kasing bilis lang ni h nagzi-zero yung error, pero itong formula na meron tayo ngayon, kasing bilis ni h squared nagzi-zero yung error. Okay? Now, if I don't ask you about an error estimate, then it's fine. You just say, sir, yung error nan kasing bilis ng h squared, yung pagiging 0. All right? But if I ask you to find an error estimate or an upper bound for the error, kailangan i-spell out nyo yung term na tinruncate nyo to get big O of h squared. That's why I wanted you to keep track of the error term. So in this particular case, the error term is h squared over 3 times f triple prime of x, and the mean value theorem guarantees us that there exists a c in the neighborhood of x such that f triple prime is equal to f triple prime of c. So ito yung gagawin nating error term, right? Where c is a number in the neighborhood of x. So coming from x hanggang x plus 2h. Now, that's the problem with C. So pag pinahanap ko kayo ng error estimate, dapat pipili kayo ng isang C sa number, isang number C between x plus, x plus 2h. Well, if I ask you about the error bound, okay. So remember, ang error bound, ito yung pinakamalaking posibleng error. Pag pinakompute ko sa inyo yung error bound, kailangan kunin niyo yung maximum ni f triple prime dito sa interval x, x plus 2h. Kasi pag minaximize nyo si f triple prime, dito sa interval na to, makukuha nyo yung biggest possible error. The biggest possible error would be h squared over 3 times the biggest possible value in terms of absolute value ni f triple prime. So, I stand corrected. Ang kukunin yung ay maximum ng absolute value ng f triple prime. Okay? Pag nakuha nyo na yung maximum absolute value ni f triple prime, makukuha mo yung worst case scenario. What is the error or what's the highest possible error in the approximation? Okay? So that's finding a forward formula. Tingnan natin yung susunod na example, unless you have questions with example 6.1. Sa example 6.2 pa rin, naman, ang gusto ko pa rin ay maghanap ng isang formula of order 2. Tapos 3 points din yung gagamitin. The only difference now is I want to go backwards. Okay? Now, if you go backward, so ibig sabihin, gusto kong makuha yung yung estimate para kay f prime of x. Gusto kong gamitin yung function value kay x, pero backward yung formula. So ngayon, pakaliwa yung pag-move ko or pag-harvest ko ng data. So ngayon, gusto kong gamitin yung function value kay x minus h at saka function value kay x minus 2h. Kasi backward nga yung formula. So you start with x, go backward 2 steps in time, or in the x-axis. And those are the data that I will use. Now, again, you go back to the Taylor series expansion. We expand f of x minus h and f of x minus 2h. And again, the trick here is you replace the h in formula 6.6 by minus h and minus 2h respectively. All right? So let's look at it quickly. So lahat ng h, papalitan ko ng negative h. Or dito na lang pala. So ito ay papalitan ko ng negative h. So still f of x, si h papalitan ko ng negative h. So magkakaroon ako ng negative hf prime of x. Now the h here will be replaced by negative h, but that will still be inside the second power. So essentially this will become h squared f triple prime of x pa rin over 2 factorial. This guy will be negative h cubed f triple prime and so on. And then to get an expansion for f of x minus 2h, we replace all h's by negative 2h. So this would be negative 2h, then this would be plus 4h squared, this would be negative 8h cubed, and so on. So kunin natin yung expansion na yun. Okay. And that's how I got these two guys. Okay. And then the same process goes on. I know that in the end, since I'm looking for a formula for f prime, I will be dividing by a factor of h. So kung gusto ko ng formula of order 2, kailangan itira ko hanggang h cube. Titira ko hanggang h cube term kasi later magdi-divide ako ng h. So matitira ay h squared. Yun yung magiging error ko. Okay? So that's why dito, naging careful ako hanggang sa mga h cube terms. Pero ellipses na lang yung mga susunod because they don't matter anywhere, ma-absorb na sila ng truncation error. Okay? Now, piliin nyo lang sino or identify nyo susunod, sino yung mga kailangang i-eliminate. Well, these guys can stay kasi sila yung function values na gagamitin natin sa formula. Of course, the f prime terms can stay because essentially we want an f prime on one side of the equation. We want to keep the ones with h cube kasi dyan magagaling yung theoretical error. So the only unwanted terms are the ones with f double prime. We don't have any information about f double prime, so they should go. So kailangan yung isipin ano yung multiplier sa first equation at saka second equation such that when you add the two equations together, mawawala yung may f double prime. Okay? But katulad kanina, you can take note that the numerical coefficient here is what? H squared over 2. The multiplier here is h squared, 2h squared. So you multiply the first by also negative 4. You retain the second one, all right? And then, yeah, you add the two corresponding sides of the equations. Katulad ng ginawa natin sa example 6.1, do your arithmetic and you will get this. The 3-point backward formula of order 2. Okay? Now, in terms of the error, you can double check that the error is, or the error term is negative 2h squared, f triple prime of c all over 3, where c is a number na ngayon naman manggagaling sa open interval x minus 2h, comma, x. Okay? And again, this is a order 2 formula, so yung error ay nagzi-zero kasing bilis ng pagzi-zero ni h squared. And that's obvious because this is the error term. So essentially, nakadepende yung pagzi-zero ng error sa pagzi-zero ni h squared. Kasi lahat na natitirang factors ay puro constants. Alright? Hindi nga lang natin ma-pinpoint ano yung constant na yon kasi hindi natin alam ano si number c. But nevertheless, this is a constant multiplied by 2/3. So itong error na to will go to 0 as fast as how h squared approaches 0. Okay? Kaya nagme-make sense yung pagtingin natin ng order ng error. Okay? Now, any questions? Napatingin ako sa orasan ko, medyo ang bilis ng oras, 9:11 na kagad, 9 minutes left. And we're still in page 9 out of 13. So do you have questions? Mukhang straightforward naman, ano? So, tingin pa tayo ng isa pa. Example 6.3, ito, medyo challenging. 5-point centered formula of order 4. Okay? Now, sa 5-point centered formula of order 4, centered yung sinabi. So, mag-start pa rin ako sa x. Kailangan ko yung function value kay x. Or gagamitin natin siya para dun sa formula para kay f prime. Now, this is a centered formula, so dapat si x nasa center. I need 5 points. Meron na tayong isang point, si x. So, mag-move ako 2 steps forward and 2 steps backward to get 4 more points na naka-center kay x. So, kailangan ko si x plus h, x plus 2h, x minus h, at saka x minus 2h. Right? And the function values at these 5 guys, sila yung gagamitin ko dun sa formula para kay f prime. Okay? And you might be anticipating a very accurate formula here, and you will be right, because our formula of order 4 will have an error that vanishes as fast as how h to the 4th approaches 0. So ang bilis ng pag-zero ng error nito as you decrease the step size. Pero ano yung cost niyan? Marami tayong data points na ginagamit. At actually, yung derivation ay hindi ganun kasing ganda nung dalawang derivation natin kanina, because now you need the expansion of 4 function values. All right? So kailangan ko yung expansion ng 4 na function values na to in terms of the derivatives of f. All right? So sinulat ko lang siya dyan. I hope now you can imagine how I got these expansions. Balik lang kayo sa 6.6. Palitan nyo lang si h by the appropriate step size. So for instance, to get f of x minus 2h, balik kayo sa formula 6.6. Palitan nyo lahat ng h's na nasa formula na yon by negative 2h. So hopefully then you will get this 4 expansions. The next step is to identify, or actually yung susunod palang step ay identify nyo kung kailan kayo dapat tumigil sa pagsusulat ng terms ng expansion. We want the formula of order 4 para kay f prime. But we know f prime always goes with an h. All right? So, ibig sabihin dun sa final formula, i-anticipate nyo magdi-divide tayo by a multiple of h. So, kung magdi-divide ako later by a multiple of h, tapos after the division, gusto ko may h to the 4th na matira, so kailangan i-keep track ko hanggang kay h to the 5th. Right? And that's why you will notice here, kinuha ko hanggang kay h to the 5th, tapos ellipses na lang yung mga natitira. Para ma-keep track ko ano yung theoretical error. Right? And then after you have written the expansions up to the appropriate term, ang susunod yung gawin, tingnan nyo, sino yung mga dapat mawala. Okay? So obviously, these guys should remain in the formula because they are the function values that we will keep. Likewise, yung f of x, pwede rin siyang matira. Etong may f prime, dapat matira rin yan para mamaya meron tayong f prime na isolate sa isang side of the equation. And then as we have analyzed earlier, dapat matira yung may h to the 5th. Kasi sa kanila manggagaling yung error term. But everything in between f prime and and the 5th derivative of f should vanish. Dapat mawala itong mga terms na yan. So, we must choose coefficients to the 4 expansions, all right? Constants a, b, c, and d, so that when I get a times this guy plus b times this guy plus c times this guy plus d times this guy, dapat yung sum na yon ay wala na yung mga terms na may f double prime, f triple prime, and 4th derivative. Kasi nga wala tayong info about these derivatives, right? So dapat wala sila dun sa formula na makukuha natin. Okay? And that's what you need to solve for. Okay? So pag sinet up nyo yan, sige, let A be the multiplier to this, B to this, and so on. So pag in-expand nyo yan, ito yung makukuha natin. Okay? Minultiply ko lang bawat expansion by the constant that we are looking for, A, B, C, and D. And again, gusto kong mawala itong mga differently colored terms. Okay? Pag inad natin yung mga right-hand sides, so makukuha natin ay eto, plus eto, plus eto, plus eto. Siya yung may f double prime of x. So basically, kung makikita nyo to, lahat sila ay may h squared f double prime of x over 2 factorial. Ito rin ay common dito. Ito ay common dyan. Tapos ito ay common dyan. Gusto ko, pag inad ko tong mga equations na to, mawawala yung mga kulay red. Right? Pero lahat ng kulay red, merong coefficient na h squared f double prime of x. So, ibig sabihin, ang gusto kong mangyari dun sa mga red, yung 4a plus b plus c plus 4d should be equal to 0. Right? Kinuha ko yung numerical coefficients nila. Ito ay may 4a, ito ay may b, ito ay may c, ito may 4d. Essentially, pag inad mo yan, meron pa yung h squared f double prime of x all over 2 factorial. Pero common factor naman yon. So it is sufficient to require 4a plus b plus c plus 4d to be equal to 0. That's our first equation. Yun. Tapos ganun din yung gagawin natin sa blue. Dapat pag inad natin yung mga kulay blue, dapat magzi-zero sila. Pero if you notice, yung mga kulay blue na terms, lahat sila ay may h cube f triple prime over 3 factorial. So common factor nila yan, pwede nating i-factor out. So we can just forget about them and find a condition in terms of their coefficients. So ang gusto ko naman para dun sa mga kulay blue, i-add ko yung mga coefficients nila, dapat magzi-zero. So you want negative 8a minus b plus c plus 8d to be equal to 0. That's how I got the second equation. Okay? And then ganun din dito sa purple. Right? So from there, I'm going to get 16a plus b plus c plus 16d equals 0. And now we have 3 equations with 4 unknowns. Tatlong equation, tapos apat yung undetermined constants, a, b, c, and d. So here we have a what? We have an underdetermined system kasi mas marami yung unknowns, mas marami yung degrees of freedoms kesa dun sa equations. So you have the options here. Pwede nyo itong ipasolve sa isang solver. So hindi pala yun yung first option. First option ay solve nyo to by hand. So I hope marunong kayong mag-elimination method or substitution method from high school. Kasi wala na kayong Math 17, ano? So diretso kayo Math 36 sa college. So hopefully nung high school na-discuss paano mag-solve ng system of linear equations. So mag-elimination kayo or substitution to find the solution here. But we anticipate infinitely many solutions because we have an undetermined system. Mas marami yung variables kesa sa equations. So mas marami tayong degree of freedom. So there would be infinitely many solutions to this. Or kung masyadong malaki yung system, or kung ayaw nyo lang mag-solve by hand ng elimination, pwede kayong gumamit ng online solvers. Ano? So I guess MATLAB can do the job for you, or you can use Mathematica or any online solver. Papayagan ko kayo pag solve ng linear system kasi ang tinetest ko naman dito ay kung kaya nyo mag-derive ng formula. So intermediate step lang naman yung pag-solve ng system, and that's algebra. I don't want to test you on that, and I don't want you to penalize if you commit a mistake in solving the system. So pwede kayong maghanap. After ng klase, Google nyo kagad. Online solver for system of linear equations. Ano? So, or search nyo sa help ni MATLAB how to solve a system of linear equations. Sa Math 175, i-discuss natin kung paano mag-solve numerically ng mga linear systems. Pero dahil wala pa tayo doon, so okay pa kayong mag-download or gumamit ng online solver para rito. Alright? Now, if you use a solver or you solve it by hand, you can find a solution, say, of this form. So sabi ng solver ko, ito yung itsura ng mga solutions. A is a parameter. A could be any value. Yun yung ano natin. Yun yung free variable natin. Kasi infinitely many solutions nga. So you can keep A. You can give it an arbitrary value. Pero dapat si B ay equal kay negative A. Si C ay equal kay 8A. Tapos si D ay equal kay negative A. Where A is a free variable. It could be any real number. Of course, except 0. Ayaw mong gamitin si A equals 0 kasi pag si A ay 0, lahat ito ay magsi-0, so you don't end up with any formula. Okay? So, pick any non-zero real number, use that as your value of A, you get a quadruple of coefficients that will make this inequality true. Tapos ang gagawin nyo, gamitin nyo lang yung mga A, B, and C, D values na yon dito sa expansion na to. And if your solver is correct, then after you add these four guys, mawawala itong colored terms. In this particular example, I chose A equals 1. Ito yung sinasabi ko dati na pwede tayong magkaiba-iba ng formula. Alright? So you could pick, there's a free variable A, so you can pick your favorite number to be your A. Halimbawa gusto mo ay A equals 17, A equals pi, A equals E, A equals the golden ratio for the heck of it. Ano? So bahala kayo pumili kung ano si A. Most of the times, our formulas will simplify to the same thing. Sometimes it won't. Pero yeah, meron tayong freedom really to have a different formula. Okay? So pag ginawa ko si A ay equal kay 1, so ibig sabihin, this would be 1, this multiplier would be 1, and then this multiplier would be negative 8, this multiplier will be 8, this multiplier would be negative 1, following this assignment. Ano? So I will get this, i-add ko yung mga right-hand side, tapos i-add ko yung mga left-hand side, tapos ngayon i-add ko yung mga right-hand side, and as promised, you see, tama yung solution ko kasi yung right-hand side, nawala na yung second derivative hanggang kay fourth derivative. Natira lang ay 12h f prime minus 8h to the fifth all over 15 times the fifth derivative plus the higher order terms. And then once you come up with this, the next thing to do is divide both sides by 12h para ma-isolate si f prime. So essentially, you will get this guy, right? So the error term is this, negative 2h to the fourth all over 45 times the fifth derivative of x. Now, to account for the infinitely many terms that follow, you can simply say that the error is negative 2h to the fourth over 45 times the fifth derivative of f evaluated at c. Again, that's the power of c. Ano? So yung infinitely many number of terms na to napapalitan lamang ng f prime or ng fifth derivative ni f evaluated at the unknown number c between x minus 2h and x plus 2h. And you might be thinking, sir, saan nanggaling yon? Bakit yung infinitely many terms na nandyan ay pwede mong palitan ng c lamang or function value ng derivative kay c? Well, that's thanks to the mean value theorem. Okay, and I guess there's a part in the previous modules that I asked you to read as a reading assignment. Meron dong derivation kung bakit etong napakahabang term na yan napalitan lamang neto. So kindly take a look at that again. But here we are. We get a second order 5.4 centered formula for f prime. Okay. I hope you got the gist of the process here, because on Monday I will ask you to derive some basic formulas, not just for f prime, but you can also find formulas for f double prime, right? Kung nandito ka na sa expansion na to, tapos f double prime yung pinapahanapan ko sa inyo ng formula, so dapat eliminate nyo si f prime kasi ayaw nyo ng mga derivatives, function values lang yung usapan na gagamitin natin dun sa ating derivative formula. So this should be gone. Tapos si f prime naman yung si f double prime naman yung ititira nyo. And then you cancel all the unwanted terms. And then if you find A, B, C, and D such that this will be attained, so makukuha yung formula ay order, anong order? Ang makukuha yung formula ay order 3. Bakit order 3? Kasi para magkaroon ka ng ng f double prime, magdi-divide ka sa final step ng constant times h squared. Kinip mo hanggang h to the 5th. So pag nag-divide ka ng h squared para ma-free up si f double prime, etong h squared na to magiging f cubed. So makakuha ka ng formula of order 3. Okay? So yun yung gagawin niyo sa Monday. So, but I still have a couple of examples here left. So, yeah, dalawa pa eksakto yung formula, yung examples na to. So I'll ask your lab instructors to discuss example 6.4 and 6.5. Example 6.4 will give you an idea how to use the formulas that we derive to get approximate for some derivatives. Medyo meron yata ditong typo, yes. Ito ay 3-point formula. Ito ay 3-point backward formula. Alright? So ipapadiscuss ko sa lab yung example 6.4 para lang magkaroon kayo ng idea paano i-implement yung formulas. And mas madali siyang gawin talaga sa Excel. So I usually use Excel or a spreadsheet to implement numerical differentiation formulas. Or pwede naman kayo mag-MATLAB or mag-Python if you want. Pero napakasimple niya, kaya siya ng spreadsheet. So we can have that there. And then your lab instructors will also discuss example 6.5 kung paano yung sinasabi ko kanina na magko-compute kayo ng formula para kay f double prime. Okay? And I guess that's it. We're done with module number 6. In module number 7, we will see a peculiar phenomenon wherein in a machine implementation, makikita natin na hindi lang natin pwedeng palitin si H. There is a threshold na kapag mas lumiit pa si H doon, machine precision will kick in. So the very finite nature of our computers or their limitations will come into play na magsasabi sa atin na, oo nga, yung theoretical method natin, ang sabi, dapat si H ay mag-approach ng 0. Pero pag pinagawa natin sa computers yung computations, magkakaroon tayo ng problema because of machine precision. Computers cannot handle dividing by a very small number. And remember, our formulas always has an H or always have a formula or always have an H in the denominator. So when H is very large, yung denominator, when H is very small, the denominator is very small. Dividing by a very small number is not a good thing for computers to do. So magkakaroon tayo ng problema. And that's what we'll try to address next week. All right? So we'll stop here unless you have questions. So again, on Monday, you will have a laboratory exercise. I'll try to write one tonight. So hopefully by tomorrow morning, you'll see it uploaded in Canvas so you can think about it. All right? So, pero I anticipate maiksi lang to. Probably I'll just ask you to derive a certain formula. Sabihin ko kung ilang points, anong order, at saka kung forward, backward, or centered. And then I will ask you to implement it, to approximate some derivatives. Right? So yun yung gagawin niyo sa exercise. But before that, your lab instructors will discuss with you examples 6.4 and 6.5. Okay? So that's it, guys. Any questions, any comments, concerns, violent reactions, anything you want to share before we adjourn for the week? All right. So if there are none, so thank you guys for joining me this early in the morning. Enjoy your weekend and see you on Tuesday. All right. Bye, guys.
Thank you po, sir.
Thank you po.
All right.